Now we're going to do dividing monomials. So we know what a monomial is. It's one term. We've already multiplied monomials, and if you remember, what did we do with our exponents when we multiplied monomials with the same base? We added those exponents. So multiplication and division are opposites. So now, what do you think that we're going to do with our exponents here? We're dividing. So now we're going to subtract our exponents. So the rule, the formula that we use is if you have the same base, you keep it, which is x, and now I subtract a minus b. And remember, you can only have positive exponents. So for number one, these are all numerical bases. They're still monomials. They're still one term. So I'm going to keep the same base, which is 12, and 7 minus 5 is going to be 2. So it's 12 squared. A lot of times what happens is students want to just divide 12 divided by 12 to give you 1, but that's not what we're doing here. Remember, if I wrote this out in expanded form, this would be like me writing 12 times 12 times 12 times 12 times 12 times 12 times 12 all over 12 times 12 times 12 times 12 times 12. Oh, that's a lot of work. And remember, anything divided by itself is 1. So I could do those cancel out, those cancel out, that cancels out, cancels out, and cancels out. And what does it leave me with? It leaves me with 12 squared. So instead of writing all this out in expanded form every time, there's a rule, and it's simple. It's like a shortcut. So we subtract our exponents. And we've already talked about that and looked at that in expanded form back in our notes. Woo, I'm okay. And back in our notes earlier when we did negative exponents. So number 2, it's going to be negative 6 to the 8th power. Here I have 4 to the 9th power. Here I have 9 to the negative 2 power, but remember I can't have a negative exponent, so what happens is I put 1 over 9 squared. And you can kind of look at this, and this is also in your notes from a long time ago, but you can see. You've got, if I wrote this in expanded form, 9 times 9 times 9 over 9 times 9 times 9 times 9 times 9, these guys cancel, 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 and it leaves me with 1 over 9 squared. So even though I got a negative exponent, remember I still had to flip my reciprocal and that became positive, and that's the y behind it. Number 5 is anything to the 0 power is 1. 6 minus 6 is 0. Anything to the 0 power is 1 because anything divided by itself, 8 to the 6th, is exactly like 8 to the 6th, and it's 1. Over here, I have negative 5. This is tricky, so be careful. I have negative 1 minus 2. So think of this fraction bar when you use your rule. It's negative 1 minus 2, which is a negative 3. So I have to flip it. 1 over negative 5 to the 3rd power. Okay? So that's when you have numerical bases. Let me erase that out. What happens when we have variable bases? The same thing. If the base is the same, we keep it, and I get x to the 8th, subtract my exponents. Here I get w to the negative 5th power, which is 1 over w to the 5th. I'm going to box my answer. Here I get 1 minus 4, which is p to the negative 3rd, which is 1 over p to the 3rd. Over here, I can look and I can see I have more m's upstairs. So I'm going to have 3 minus 2 is 1m upstairs, and 6 minus 2 is 4, so I have mn to the 4th power. I'm subtracting those. This base is the same, so I subtract these exponents. This base is the same, so I subtract these exponents. But I'm still ending up with one monomial, one term. So here I have 2 minus a negative 3. 2 minus a negative 3 is a positive 5, so be careful because that's r to the 5th. Negative 5 minus 2 is s to the negative 7th. So when I have a situation like this, I'm not going to change r. R is going to remain upstairs as the numerator. The only one I'm turning down is this s. So I have r to the 5th over s to the 7th. Can you see that? This guy remains positive, so I'm going to keep him where he is, but this is a negative exponent, so he comes downstairs and his exponent becomes positive, okay? So when I look at number 12, this is really a to the negative 7th, b to the 6th, and my c's cancel out. C to the fourth over C to the fourth is 1. And so now the only guy that's going to come downstairs is A. So A to the 7th comes downstairs, and B to the 6th remains upstairs. So that's my final answer. Okay? If you're struggling with those, again, come see me in tutoring. All right. Now what happens when you have them both together? All right. So I'm going to do the odd ones with you. Number 13, 15, 17, 19, and 21. And then I want you to go back and do the evens to make sure that you're understanding that. So here I'm going to do 24 divided by 8. Remember, my numbers, they do what they're told. We've been dividing numbers all along. And so here I get 3c to the 7th. Number 14, negative 36 divided by 4 is a negative 9. And then 6 minus 4 is 2, so I get k squared. So negative 9k squared. 10 divided by 2 is 5. Here I have 3 minus 4, which is x to the negative 1. All right, now, watch what happens. This 5 still remains as the numerator. 5 can be turned into rational numbers, so it's 5 over 1. My 5 is fine. He's not going to move. The only thing that's changing is this negative exponent right here, this negative 1. So I got to move my x downstairs, and it becomes positive 1. Do I really need that exponent there, though? I don't. It's understood to be x to the first power. So I'm going to make it simple because that's what I do, but that's not going to erase. And I'm just going to have x over 5. Oh, darn it. I said I was going to do the odds, and you're going to do the evens. All right, so I'm not going to do 16. I'm going to jump down over to the next page. And number 17. Now here, 3 over 6 is a fraction. It's a rational number. I reduce fractions, remember. So 3 over 6 becomes 1 over 2. And I get h4 minus a negative 1 is a positive 5. I'm filming, girls. I'm filming. So I get 1 h to the 5th over 2. That's my answer there. All right, so number 19, I'm going to reduce my fraction, negative 3 over 18, to give me negative 1/6. What happens with my variable? 6 minus 10 is r to the negative 4th. Now notice what I'm doing here. I'm subtracting them and I'm keeping them as a numerator, okay? It is not until the very end that I'm going to start flipping. So negative 1 over 6 remains as negative 1 over 6, and then r comes downstairs, and my exponent becomes positive. You see that? Number 21, negative 28 divided by 4 is negative 7. Here I have negative 4 minus a negative 4 is negative 4 plus 4, which is 0. So those guys cancel out. And I have 5 minus 2, which is y to the 3rd. No exponents are positive, negative, so I can remain as is. Okay? All right, so you guys try the even ones, and I'm going to write those answers on the board, but I won't go through the process with you, so you can just check yourself. All right, I'm going to start with 14. So 14 is going to give us 9k squared. 16 is going to give us negative 4 over a to the 8th. 18 is going to give me 5b to the 10th over 8. Okay, I'm going to erase those and we'll move on down. Screwing up on me. All right. All right, let's go to 20. So number 20 is going to be 2 over 5w to the 11th. Number 22 is 8n to the 6th over m to the 5th. All right. And now down here on the bottom for this mixed practice, now we're multiplying and dividing. So remember our rules for multiplying and dividing when we have fractions is we can do the numerator as one operation, and then we divide at the end. So I'm just going to go ahead and practice with you on number 23. So here I have 12x to the 9th over 6x to the 6th. I can simplify this even further by dividing. 12 divided by 6 is 2. I subtract my exponents. 9 minus 6 is x to the 3rd. Everybody's positive, so that remains my final answer. So if you want to test yourself to see how you do on 24 through 28, or 24 through 30, go ahead and do that, and I'll write the answers up here. If you think you've got it, you're good, and then we'll just practice in class the next time I see you. Otherwise, I'm just going to go ahead and pop up these answers real quick. 24 is going to be 3 over 14 n to the 7th. 25 is negative 45a to the 7th. 26 is 72 over w to the 6th. 27 is 5d squared over 2c to the 7th. 28 is negative 6s to the 4th over, oh, I'm sorry, that's s to the 9th, my bad. Negative 6s to the 9th over 5r to the 5th. Number 29 is negative 2x to the 5th, y to the 6th. And number 30 is 19n to the 3rd, n to the 7th. Okay, so if you're getting that, fantastic. If not, you need a little bit more practice. Come back and see me in tutoring, and we'll get these two rules down, all right? See you in class.